Hello everyone, my name is Koranit, and today Piroonkarn and I will be presenting our Physics Quarter 3 project, and the topic that we will be teaching today is about the bending of light. The most fundamental property we learn about light is that it travels straight, yet all optical devices invented by humankind require light to bend. Lenses focus light to produce an image. Optical fibers bend light in loops all around your neighborhood to enable lightning-fast internet speed, and even the human eye bends light to create vision. While it is true that light's direction can be changed by optical phenomena such as refraction and reflection, the path of light will always remain straight. So what really is bending of light? Let's find out. So what is refraction of light? Refraction is the bending of light. It also happens with sound, water, and other waves, as it passes from one transparent substance into another. This bending by reflection makes it possible for us to have lens, magnifying glasses, prisms, and rainbows. Even our eyes depend upon this bending of light. Without reflection, we wouldn't be able to focus light into our retina.
Causes of bending of light. The bending of light in refraction is caused by the change in speed of the light wave when it enters a new medium. For example, when light travels from air into water, it slows down, causing it to continue to travel at a different angle or direction. If light enters any substance with a higher refraction index, it slows down. The light bends toward the normal line. If light enters into a substance with a lower refraction index, it speeds up. The light bends away from the normal line. Snell's law. Snell's law gives the degree of refraction in relation between the angle of incidence, the angle of refraction, and refraction indices of a given pair of media. We know that light experiences the refraction or bending of when it travels from one medium to another medium. Snell's law predicts the degree of the bend.
What about the amount of bending of light? The amount of bending of light depends on two things. First, change in speed. If a substance causes the light to speed up or slow down more, it will reflect or bend even more. Second, the angle of the incident ray. If the light is entering the substance at a greater angle, the amount of refraction will also be more noticeable. On the other hand, if the light is entering the new substance from a straight on at 90 degrees on the surface, the light will still slow down, but it won't change direction at all. Example of refraction of light in real life. First, mirage and looming are optical illusions resulting from refraction of light. Secondly, a swimming pool. It always looks shallower than it actually is because the light coming from the bottom of the pool bends at the surface due to refraction of light. Third, formation of a rainbow is an example of reflection of light, as the sun rays bend through the raindrops resulting in the rainbow. When white light passes through a prism, it's split into its component color, red, orange, yellow, green, blue, and violet due to reflection of light. So, applications of refraction of light. Refraction has many applications in optics and technology. A few of the prominent applications are listed below. First, a lens. It uses reflection to form an image of an object for various purposes, such as magnification. Second, spectacles. Worn by people with defective vision use the principle of refraction. Third, reflection is used in peepholes of house doors, cameras, movie projectors, and telescopes.
Okay, so as you can see right here, it reflects inside the water steam without it going like straight forward. Okay.
So is that a 48.8 degrees?
Yes.
There you go.
So our laser is not as strong as the video, but you can see that the water,
You can see that it's like come down.
Nice.
instead of it going like straight like that. According to the experiment video, the laser light gets reflected inside the stream. The surface of water is reflective both on its surface and below the surface. In this case, water, due to the change in speed, it will change directions. However, when a certain angle called the critical angle is reached, it reflects back. The critical angle is the smallest angle of incidence for which light is totally reflected. The critical angle of water is 48.8 degrees. When the angle of the beam crosses the critical angle, the light does not go out of the stream and total internal reflection takes place at the end of the stream. There is a lot of turbulence, so the continuous reflection change breaks or scatters down and the laser lights get scattered. Because of this phenomenon called total internal reflection, the light appears to be traveling along with the water stream.